Hey, this is Uwe Artmann again. I'm CTO of Image Engineering, and in this session I'm going to talk about shading. So we differentiate in different categories of shading. So one is the luminance shading, also very often called like relative illumination or vignetting. So this describes basically the fall off from the center to the corner, so that you have darker corners than you have in the center. An issue that is very common, for example, in mobile phones, where you have very tiny lenses that needs to be designed to fit in our small mobile phones. So there you have a lot of this luminance shading. Another effect that you have also in many different devices, particularly also in mobile phones, is the so-called color shading. So due to filter effects, so a variation in the transmission of finalcut filters or in the filter design on the sensor, you have a different spectral sensitivity in the center than you have in the corner. So that means that you have a different, or that you have a color cast. So typical is that you have like a greenish center and a magenta corner or vice versa. So this is something that you want to calibrate on production line or to get rid of, but also the measurement for that is very needs to be done. And this particular color shading needs to be done with different illuminants, because color shading is depending on the illuminant. You have a different color shading when you use an A light source and you use a D50 light source. And that's where IQLED technology comes into play, because it can create these illuminants easily with the same light source. So both color shading and intensity shading, if you are in production line, are tested with a so-called flat field. So the device on the test captures a uniform area, and from that you can perform your measurements. So in this example you see there is a lab technician placing a camera in front of a diffuser. Of course, in production line, a machine would do that, and the diffuser doesn't have to be as large as it's shown here. There are different devices of image engineering that can be used for that. So, for example, the LE7, which is a half-meter integrating sphere, is designed for back illuminate transparent test targets. You do things like dynamic range or noise measurement with that, but you can also put a diffuser in the chart plane so that you just have a large diffuser and can then back illuminate this. So you have a high uniformity over the entire area of that because of the large sphere that we use. So that is a device that is used on many production lines out there. Then we have the CAL1 or CAL2, also specifically designed with the IQLED technology to provide a very uniform flat field. So the CAL1 has slightly higher uniformity, while the CAL2 is smaller in form factor. So that depends a little bit on the constraints that you have on your production line about which device fits best for your needs. So the typical thing is that you capture this flat field and then you can feed that into a software. So you see here as an example the IQ Analyzer software, and then you can calculate luminance shading, color shading, and so on with that software to also extract from that all the information that you need for shading correction. One particular problem that you might face with some type of cameras is with fisheye cameras. So you see here fisheye security camera footage. So you see the entire wall of the building. So this is a 180-degree field of view, and just logical or optical that you cannot reproduce a flat field diffuser, so a flat diffuser with such type of camera. So most of the times the lens is, of course, sticking out, so it's not a flat front lens, so that you cannot really bring it close to the diffuser, and then it just optics that if you have 180-degree field of view, you cannot see the entire diffuser. So what to do about that? Because also fisheye lenses suffer a lot about relative illumination, so you want to calibrate that. So one possibility would be that you place a stable light source Cal 1 or Cal 2 or LE7 in some distance to the camera, and then you rotate the camera. And step by step, you measure then different locations. So you see that here in this animated GIF. So that is a Cal 2 light source, and then the camera was rotated. And with that, we can very accurately measure the shading. The problem is you need a lot of images, you need to rotate the cameras and so on. So this can be done in lab, or we did in lab. But this is not what you want to do on production line, because you don't want to capture hundreds of images just to get the flat field or the shading. What you can do for that is using the Cal 3. So the Cal 3 is a light source based on IQLED technology with a bowl-shaped diffuser. So you have a diffuser that has a shape of a bowl, so you can bring your DUT, so the device under test, actually into the diffuser. So then the device itself will see from all angles just the diffuse white, so that you do a flat field calibration with your fisheye lens or fisheye camera on production line. So many customers in automotive environment use these devices on production line so that they can test there and calibrate their cameras. Many customers, or a lot of customers, see this and say, oh great, this is something that I was looking for. The problem is there are some cameras out there that cannot deal with this relatively small opening of the Cal 3. So that's why we have the Cal 3 extra large. So if, depending on the form factor or either the diameter of the front lens or that the device that you want to test is maybe attached to a board or in a larger housing so that you cannot get it into the diffuser of the Cal 3, the Cal 3 extra large is your device. So with that, you have more than 20 centimeter opening so that you have a lot of space to put your camera right into the diffuser to do that kind of calibration. So yeah, you have 225 millimeter maximum opening in there. So you place your DUT right inside the diffuser and can do the calibration. So a very powerful tool, also used on many production lines in the world to calibrate fisheye lenses. So thanks a lot for now, and see you in other sessions. Thank you.